Hello children, so let's discuss amides. Okay, so the general formula is R C double bond O NH2. This is our acid amides. Now let's go a quick into its preparation. So I have three methods of preparation lined up. Adila, the first one is by Ammonium, okay, of your acid derivatives. This we have discussed and it follows the typical nucleophilic acyl substitution reactions. You can take either the acid chloride or the acid anhydride, okay, and you treat either one of them with ammonia. What you will get, you need two molecules, okay, what you will get is the corresponding amide, and in the case of if you had taken the acid chloride, you would have got ammonium chloride as a side product. If you had taken the anhydride, I would have got the ammonium salt of the acid, that is the byproduct. Okay, so this is a typical reaction which goes by our mechanism which we have discussed extensively. Okay, another method of preparation is by pyrolysis of ammonium salts of acids. Okay, either you take ammonium salt of an acid and you just subject it to heating, and this has to occur in presence of some acid, and we get the corresponding amide and water. The acid is just to prevent this particular reaction from happening. That is, this ammonium salt should not dissociate to form ammonia and the acid. That prevent the acid nammal Another method of preparation is by the partial hydrolysis of cyanides. So you can take alkyl or aryl cyanides, okay, and you treat it with water, and this has to be at 100 degrees Celsius, and you have to have polyphosphoric acid, and you then dilute it with water, and what you get is the corresponding amide. Okay, so that's all about the preparation, and now let's have a look into the reactions, the various reactions that we see. Discuss as with all that we have done, we discuss the nucleophilic acyl substitution. Okay, now in what you will see that when compared to your acid chlorides നമ്മുടെ anhydrides you can see the structure here. Okay, this is how my amide is. So now this nitrogen has a lone pair of electrons on it. So what happens is that because of the electronegativity difference between carbon and oxygen, you see this would move to this side, because of the positive charge that has developed on our carbon, there is a slight positive charge, this comes to this. Okay, and you see that there is a resonance structure there. Okay, so ഇത് കാരണം എന്താ സംഭവിക്കുന്നത് വെച്ചാൽ നമ്മുടെ ആ കാർബണിൻ്റെ the electron deficient center, it was supposed to be an electron deficient center, എന്നാലല്ലേ ന്യൂക്ലിയോഫിലിക് അറ്റാക്ക് വളരെ നന്നായിട്ട് ഈ കാർബണുമ്പോൾ വരുള്ളൂ. അത് because of this push of these electrons, this lone pair of electrons towards the carbon, the electron deficiency is somewhat compensated. Okay, അപ്പോൾ ഇത് കാരണം what happens is that it is not as so nucleophilic attack അവിടെ വളരെ difficult ആണ് when compared to acid chlorides and anhydrides, and in general we say that actually they are not used as acylating agents. Okay, we don't use them there. Okay, you even cannot hydrolyze it by water. But if you do want to have an hydrolyzed product, you have to heat it with dilute acids or alkali. For example, if I have RCONH2, that is this, if I treat it with water in presence of an alkali, okay, you heat it, I will get the corresponding salt, okay, sodium salt of the acid, and ammonia is liberated. Okay, so this is what we see. Okay, another thing is that we can have to discuss is, in general ഈ NH2 ആയോണ്ട്, see RC double bond O NH2, so we have a lone pair of electrons. So generally that lone pair ഒരു tendency to donate is what we talk about as in term of a basic character. പക്ഷേ ഇവിടെ your amides are usually seen to be neutral. Okay, now why it is neutral is because, see, നമ്മുടെ ഇവിടെ എഴുതിയ പോലെ you have see this resonance, the structure that you see between it resonates there, that electron, the lone pair of electron is involved in this resonance structure. അപ്പോൾ what happens is that അപ്പോൾ നമുക്കൊരു equivalent structure നമുക്ക് വേണമെങ്കിൽ ഇങ്ങനെ എഴുതാം, CONH2, and you can have a del minus, a del positive here, and you can think of, see, the density being moving in this direction. അപ്പോൾ നമുക്ക് ഇത് കാരണം ആ ഒരു lone pair of electrons is not, see, this lone pair is not available. Okay, so that is why we say that the protonation it is not available. So that is why we say that the amides are usually have a neutral character. Okay, now let's go into reduction reaction. What happens when you reduce an amide? So now reduction can be achieved either by using lithium aluminium hydride, or you can take hydrogen over platinum or nickel. Okay, you can use these other common reducing agents, okay, that you see, and basically what you will get is the amides, okay, will get reduced to the corresponding amines. Okay, so I need 4H here and water. So this is the typical reaction that you will see for any alkyl or aryl or I'll get it the corresponding amines ആണ് എടുക്കുക. And next set of reactions that we would like to look is what happens when you do dehydration. Okay, നമ്മൾ partial hydration of എന്താ പറയുക alkyl cyanides-നെ ചെയ്തപ്പോൾ we prepared your amides. So ഇതിൻ്റെ ഒരു റിവേഴ്സ് റിയാക്ഷൻ ആണ് ഇവിടെ നടക്കുന്നത്. So that is when I subject my amides to dehydration, and this is occurring either when you heat it with some phosphorus pentoxides or some thionyl chloride, and when you do that, what I see that I get the corresponding cyanide, alkyl cyanide or aryl cyanide, whatever. Okay, this is the what happens when it undergoes dehydration, because it's giving out water. Now another set of reaction that we can think about is the Huffman Huffman degradation. degradation. Yeah. Okay. So this is a typical reaction. Idinte now immediately Hoffman's degradation കേട്ടാൽ നമ്മൾ ഉടനെ bromine and NaOH, bromine and NaOH or KOH you can take. Okay, ഏതെങ്കിലും ഒരെണ്ണം എടുക്കുക. This is our reaction. So what happens is that when I take amides, okay, they will react with your bromine, and it is heated in with bromine in your sodium hydroxide or potassium hydroxide, and I will get primary amines, but the thing is that with one carbon less. Okay, so ഇതാണ് ഒരു സ്റ്റെപ്പ് ഡൗൺ ആണ് നമുക്ക് വരുന്നത് ഹോമോലോഗസ് സീരീസിൽ തൊട്ട് or not homologous series, sorry, it is not the same family, but you're getting one carbon less. Okay, so ഒരു ഡിസെൻഡിങ് ആണ് നമുക്കിപ്പോൾ especially when you go for a series of reactions or when you want to do a conversion, okay, and you want to have one carbon less, you have to go through this reaction. So this is Hoffman degradation, and the other products, if I have taken KOH, okay, let me take it as KOH, I will get KBr, and I will get potassium carbonate and water. And if I go to balance that reaction, it will be 4 Br2 plus 4 KOH to give me 2 and 2 molecules of water. So this is the Hoffman degradation reaction. And then we come to the last reactions that we have is when it reacts with nitrous acid, okay, HNO2. What I will get is the corresponding acid, water and N2. Okay, now this reaction is very very important because നമ്മുടെ ഈ എത്രമാത്രം നൈട്രജൻ ഇവോൾവ് ചെയ്യണത് അത് നമ്മളൊരു ക്വാണ്ടിറ്റേറ്റീവ് ആയിട്ട് നമുക്ക് മെഷർ ചെയ്യാം. ഓക്കെ, സോ ഇതിൽ എത്ര, ആൻഡ് ദിസ് യു ക്യാൻ യൂസ് ഇറ്റ് ഫോർ ദ എസ്റ്റിമേഷൻ ഓഫ് എമൈഡ്സ്. എത്ര എമൈഡ്സ് ഉണ്ടെന്ന് അറിയണമെങ്കിൽ എത്ര നൈട്രജൻ ഇവോൾവ് ചെയ്തു എന്ന് പറഞ്ഞ് ഉള്ള റേഷ്യോയിൽ ദിസ് ഇസ് എ റിയാക്ഷൻ വി യൂസ് ഫോർ ക്വാണ്ടിറ്റേറ്റീവ് estimation of your amides. Okay, with that we are done with amides. Thank you.